Good morning, algebra scholars. I have a new toy at my house. I have this like plastic whiteboard that I stuck on the wall. You can see the tape in the picture, but I made up these notes yesterday for you to look at. Before we move on to 9.3, we're going to define trig functions according to the unit circle. So you can see on the on the left side here, we've written out some definitions. Okay, so if you do want to look in your book, this is on page 478. They're sometimes called circular functions. So wherever we intersect the unit circle, that point is xy, just like a normal coordinate graph. But we actually are going to define each one of the triangles that we draw on the inside by the radius as well. So the radius will always be the hypotenuse of our triangle. Always. So instead of writing sine equals opposite over hypotenuse, like we've been writing for sine, instead, let's say I draw a triangle here. Well, it's not very straight. Okay. But here's x. Y. That means this side has x length, this side has y length, and this hypotenuse is the radius. So instead of writing sine theta like we have been before, here's theta. Now we're going to write opposite over hypotenuse. That's where the y over the r comes from, opposite over hypotenuse. And also cosine is going to be adjacent over hypotenuse. So it's the x length over the r length. Of course, tangent's going to be opposite over adjacent, which is y over x. So we can define those three like that. Then, of course, your reciprocal is r over y for cosecant. The reciprocal for cosine is x over r. And then for tangent, the reciprocal is going to be cotangent, which is x over y. Of course, with those restrictions that you always know whenever we have fractions. So that's the big definition idea of 9.3. And so you write these in your notes. We're going to be using these throughout the rest of the chapter. And I'm hoping that also the other picture here from page 479, you'll notice that what we're going to do is define each one of these trig functions according to sine being equal to y and cosine being equal to x. So I want you from now on to always sort of associate cosine with the x-axis or the x value, and I would like you to associate the sine with the y value. Always sine y cosine x, sine y cosine x. And then hopefully, right, you will remember that the values of sine and cosine are the y-coordinate and the x-coordinate of the terminal side. So if I have this angle, here's my terminal side, and this right here, this xy, that's the point that we're calling xy. You could just call it cosine x, comma, cosine y as well. So that's all we have for today. I look forward to seeing you today. Hopefully our meeting goes well. All right. Good luck. We'll do another assignment later.